Hi, thanks for watching. Before anything else, let's give credit where it's due. Eric Weinstein laid down an audacious set of breadcrumbs with geometric unity. Our contribution has been to pick up those breadcrumbs and bake a loaf you can slice, turning a bold idea into something auditable, reproducible, and testable in the sky. Let me explain what geometric unity GU is in plain English. Think of two great pillars of physics that don't naturally snap together: Einstein's geometry of gravity and the Standard Model of particles. Geometric unity starts upstairs, in a bigger geometric space where fields and symmetries live cleanly. From there, we project down to the four-dimensional world we actually measure, our observation slice. The key promise is that this projection is not vibes or hand-waving. It's a controlled map that lets different teams reproduce the same physics downstairs if they start from the same assumptions upstairs. The central mathematical idea we make explicit is that projection and variation commute. In words, you can either vary the theory upstairs and then project to 4D, or project first and then vary in 4D. You get the same equations of motion. I'll say this as an equation you can read out loud. Projection composed with variation equals variation composed with projection. That's the backbone that makes downstream calculations unambiguous. Now, how do the four papers add up? Paper number 1, From Heuristic Proposal to Testable Framework. This is where we make the geometry operational. We define the missing building blocks and prove the projection variation result I just described, so the 4D physics on our slice is well posed and reproducible. If 10 groups follow the same recipe, all 10 should plate the same dish. DOI is in the description. Paper number 2, Matter and Symmetry on the Observation Slice. Next, we put matter onto that slice. In practice, that means embedding a chiral family, think standard model-like content, while fixing conventions and closing anomalies so the wiring diagram is consistent. We keep ledgers that machines can audit, so other groups can check every step line by line. This is about trust, not believe us, but verify us. Paper number 3, Quantization, BRST, and Deformation Complex. Then we quantify what small deformations the theory can tolerate and still stay healthy. We use the BS/BV machinery to keep gauge symmetries straight, classify allowed counterterms, and enforce positivity and causality. Think of these as physics building codes. If you remodel the theory, you still have to pass the inspection. Paper number 4, version 2. Turns geometric unity into a public test bench. Even if you're not on Team GU, this matters because the rig is model agnostic. Any cosmology can be plugged in and scored. We publish a small set of clear pass-or-fail checks and run them the same way every time. To keep it honest, we pre-register the rules, track every code path with hashed manifests, and use standard robustness checks, data splits, jackknifes, and controlled injections, so other groups can rerun what we did and see if they get the same answers. How it works in one breath. You take a theory, map it to the handful of observable checks on the rig, generate the predictions, and compare them directly to the sky. No hidden dials, no moving goalposts. If a check fails robustly, you fix the model or retire it. If it passes, you've earned a rung of trust. The result is a shared scoreboard that reduces debate by slogan and makes it harder for a subtle systematic to masquerade as new physics. Why is this important? The field needs transparent, repeatable standards. Paper number 4, version 2, replaces vague claims with audits. It helps observers by catching mismatches early, helps theorists by giving fast, comparable feedback, and helps students and the public because the rules are written before we look at the answers. It's science you can actually check. Bottom line, we ran ΛCDM through the test bench, and many late universe observations matched the rig's checks as expected. Where we saw tensions, we flagged them openly and invite scrutiny. The rig doesn't assume GU is right, it assumes the sky gets a vote. And that, my friends, is what our next paper, GU number 5, is all about. So, stay tuned. Thank you for watching.